So if you've known somebody who's taken geometry before, they've mentioned that they may have mentioned this thing called a proof in honors geometry. And what a proof is that you're trying to use the laws and the definitions that are associated with mathematics in order to demonstrate that something absolutely has to be true. It's not something that you've really had to do up to this point in mathematics. Because usually in elementary school and in middle school, your teacher's just demonstrating how to do stuff. I'm going to show you how to add numbers together, integers, fractions, whatever. I'm going to show you how to simplify expressions and to solve equations. I'm going to show you how to graph functions. They're just showing you the how of something. But a proof is explaining the why of those things. I'm trying to show you, demonstrate to you that this absolutely is supposed to work no matter what. And it all comes down to definitions and properties. It's basically like the laws or the rules that are supposed to govern mathematics. And you started learning these things back in the sixth grade. One of them is right here. This is called the commutative property of equality. Now, some of these things you probably just don't remember what the names of them are. And we like to know the names because then it gives us, something to label this property, something that I'm going to refer to whenever I write it in a proof. So what I would suggest doing, if you don't remember them, is just search them up. So that's what I've done. I've called up the World Wide Web and I just Google searched sixth grade math properties, and you can see if I call up one of these things here. Let me just tap on one of these. Oh, look at that adorable pink, whatever that is. Okay, so the number properties on the left-hand side, commutative property, which I just mentioned. We also have associative and identity property. Both of those things work with addition and multiplication. And then we have the distributive property. So here, let me just come back over here and illustrate each one of these things for you with some numbers instead of all of the variables and whatnot. So commutative property is the first one up. Commutative just essentially means commute. Commutative. It just means that the order of something, it doesn't matter. So commutative property. And it works with both addition and with multiplication. It doesn't work with subtraction, doesn't work with division, but it does work with addition and multiplication. So for example, let's say that I have grouped up, well, not grouped up, I don't have to group them. All I have to do is just multiply. So 2 times 3, which I'm pretty sure is 6. And then I would also get 6 if I multiplied, why did I switch colors? Come on. 3 times 2, and I get 6, right? The order of those things does not matter. And the same thing is true about addition. So if I add 2 plus 3, I'm going to get the number 5. That is a 6. I'm going to get the number 5. And then if I reverse those or flip them, what have you, I get 3 plus 2, which I'm still going to get 5. Okay, then on the flip side of this, if I try to do that with division, am I going to get the same answer? If I did, let's say 2 divided by 3, is this equal to 3 divided by 2? And that's a pretty clear no. That's not true. And then the same thing with subtraction. 2 minus 3, is that the same thing as 3 minus 2? And I'm going to go with a no. One's a negative and one's a positive. Here, back up on the division, this is less than 1 and this is more than 1. So there you go. In a nutshell, there's commutative property. What's next? We have associative property. And associative property is about grouping stuff together. And again, it's with multiplication and addition. So here, let's start with the addition one. Let's say that I take 2 plus 3, group those together, and then I'm going to add 7 to that. So we know in terms of, you may have called it PEMDAS, some teachers call it gamma, I think. You're supposed to do the parentheses of the grouping symbols first, right? So I'm going to add these two things together, and I'm going to get 5. And then I add my 7 to that. Excuse me. I'm going to add my 7 to that, and I'm going to get 12. There we go. So if I had grouped these things differently, let's say that I have 2 plus, and I associate the 3 and the 7 together instead of the 2 and the 3 together, do I get the same answer? So plus 7. So My rules are telling me that I'm supposed to add up the 3 and the 7 together first. And of course, that's going to give me a 10, and a 10 plus a 2. Oh, well, look at that. I still get my 12. And that associative property also works with, you guessed it, multiplication. So an example with multiplication, let's say that I use the same numbers here. So 2 times 3 grouped together, and then multiply that times a 7. So doing the parentheses first, I get a 2 times 3, I get a 6, and a 6 times 7, there is 42. Okay, now if I associate those numbers in a different order, associate the 3 and the 7, do I get the same answer? And the associative properties tell me, yeah, you should, you totally should. So 2 times grouped together, 3 times 7. 3 times 7 is 21, and then 21 times 2 gives us 42. All right, so yeah, associative property is working. So, and again, like what I'm going over here is just making sure that we understand that we have these certain rules or laws, and then also when we get into geometry, some definitions, some postulates, and some theorems that we can call upon in order to demonstrate that something absolutely has to be true in this idea of a proof. All right, and I think next up are some identity properties. Identity, and we have 2 of them. Let's say that I have the number 3. Is there some number that I can add to the number 3 and not change its value? And the answer to that question is 0. If you add 0 to anything, you just get that number back. It doesn't really do anything, right? Okay, and then we have a similar one for multiplication, and that one is if I have the number 3, is there something I can multiply 3 by and not change its value, that I get my number 3 back? That is not 0. Instead, that is the number 1. And in a couple of the previous videos, we mentioned this thing called a fancy one. And this fancy one functions based on this identity property of multiplication. 3 times 1 is going to give me my 3 back. Okay, and then last up, we have the distributive property. Distributive property. And the distributive property says, let's say, for example, that I have a number that's outside of some sort of parentheses. Let's say I have 2, and then inside of my parentheses, I have 5 plus 7. So notice that there is a mixture of operations here. Inside the parentheses, I've got addition. It could be also subtraction. And then I'm multiplying that by whatever number is out front. So this is 2, and then grouped up, I'm supposed to have 5 plus 7. Okay, so let's say that I'm going to do order of operations. I'm going to do what's inside of the parentheses first. So adding those 2 together, I would have 12. And then I would take the 2 and multiply it times 12, and I would get, this should be equal to 24. Okay, now what the distributive property, and I didn't do distributive property here. I just did some order of operations. I did the grouping symbols first, and then I multiplied it by 2. But the distributive property says, hey, this 2 can multiply through the parentheses. It can distribute through the parentheses. It's much more useful whenever you have some, variable expression inside of the parentheses. All right, but I'm still going to demonstrate that it should still equal 24 whenever we do the distributive property. So 2 parentheses 5 plus 7. And when I do my distributive property, distributing the 2 to both of these, I would have 2 times 5 plus 2 times 7. 2 times 5 gives me my 10, and the 2 times 7 gives me my 14. Adding those together, look at that, 24. What do you know? Okay, now one thing that I'm going to point out at this point is something that people get confused with the distributive property all the time, that this is not the distributive property. Matter of fact, I'm going to label that very quickly, not the distributive property. Here's the first one. Let's say that this is actually the associative property is what people sometimes confuse this with. Let's say that I have 2 parentheses 3 plus 5. Does this mean that I am supposed to distribute the 2 through the parentheses? Well, here, let's just work this out mathematically, as in looking at 3 times 2, the grouping, the 3 times 5, the grouping symbols, which is supposed to be 15. And then the 2 times the 15 is supposed to be 30. Now, I think that everybody would agree that the answer to that expression is just the number 30. Okay, now let's see what happens if we try to distribute the 2 to the 3 and the 5. Am I going to get the same answer? So distributing here, I would get 6. And distributing once again, I would have 10. And 6 times 10 is 30. No, it's not 30. It's 60, right? Again, this is demonstrating that these two things, it's not the same. This is not distributive property. This is absolutely incorrect. Not correct. So there's the first thing that people confuse with the distributive property. What's different about it? Take a look at this expression and look at that. What is different about it? I'm not going to answer that for you. Maybe it's completely plain and obvious. All right, so here's the next thing that people confuse with the distributive property. And it goes like this. How about I have 3 plus 5, which I'm squaring. Now notice that what I have here is a mixture of operations, just like I had a mixture of operations over here. You might think distributive property with this exponent here, taking this exponent of 2, giving it to the 3 and the 5, and let's just see what happens. But first, we have to get what the actual answer is supposed to be, which I have to do the grouping symbols here first. Adding up the 3 and the 5, I get 8, which I'm supposed to square, which is 64. So let's see if I get the exact same answer if I distribute the exponent of 2. Yeah. So if I distribute that, I would have 3 squared plus 5 squared. It's almost like the Pythagorean theorem or something. Okay, anyway, so if I were to simplify each one of those, 3 squared is 9, 5 squared is 25. I believe that gives you not 64, which, no, it's not even close, right? So again, this is incorrect. This is not correct. Not a distributive property. Instead, when we're dealing with exponents, as we talked about in a previous video, exponentiation means repeated multiplication. This would be the same thing as 3 plus 5 times 3 plus 5, which gives me my 8 times my 8. And there's your 64. Again, not a distributive property.